Hi everyone. Today we will discuss haloalkanes and haloarenes, means halogen derivatives of alkanes and aromatic hydrocarbons. One of the hydrogen atom of alkanes is replaced with corresponding number of halogen atom, then that compound is considered as a haloalkane. Similarly, when hydrogen atom of benzene ring get replaced with corresponding number of halogen atom, then that compound is considered as a haloarenes. There are various methods of preparation of haloalkanes and haloarenes, out of which haloalkanes can be prepared from different compounds. Examples are as follows. When ethanol reacts with PCl5, that is phosphorus pentachloride, it gives you corresponding ethyl chloride as a final product. Similarly, when excess of alcohol, that is ethanol, reacts with PCl3, that is phosphorus trichloride, it gives corresponding ethyl chloride as a final product. In these two particular reactions, phosphorus halides are generally used. Similarly, when excess of ethanol reacts with red phosphorus in presence of bromine, it gives you corresponding excess of ethyl bromide as a final product. When ethanol reacts with thionyl chloride, it gives you corresponding ethyl chloride as a final product. In this particular reaction, when pyridine is used as a base, this reaction follows SN2 mechanism and it gives you corresponding ethyl chloride as a major product. When silver acetate reacts with bromine in presence of carbon tetrachloride, it gives you corresponding ethyl chloride as a final product. Such type of reaction is also called as a name reaction, that is Huns-Decker reaction. When ethanol reacts with HCl in presence of ZnCl2, that HCl used is a concentrated form and hence that reagent is considered as a Lucas reagent, which gives you corresponding ethyl chloride as a final product. Similarly, when ethanol reacts with sodium bromide in presence of H2SO4, that sodium bromide is approximately about 48% used in the laboratory, it gives you corresponding ethyl chloride as a final product. When ethanol reacts with red phosphorus as well as your H3PO4 or Ki in presence of H3PO4 gives you corresponding ethyl iodide as a major product. When propene reacts with N-bromosuccinamide in presence of carbon tetrachloride as a solvent, it gives you corresponding alkyl halide as a major product. Here N-bromosuccinamide is used, so brominated product will be obtained. Ethane reacts with chlorine in presence of H mu, that is radiant energy, means Planck's constant with respect to frequency. It gives you corresponding ethyl halide as a major product. When ethene reacts with HBr in presence of CCl4, symmetric addition will take place and it will give you bromoethane as a major product. Similarly, chloroethane reacts with sodium iodide in presence of acetone. It gives you corresponding ethyl iodide, which is also known as a Finkelstein reaction. And when ethyl chloride reacts with any metal fluoride like AgF, Hg2F2, AgF3 or AgF5, it gives you corresponding ethyl fluoride as a major product. So these are the various methods of preparation of your alkyl halides in laboratory. When ethene or propene reacts with HBr in presence of peroxide, so when unsymmetrical alkene reacts with an unsymmetrical reagent in presence of peroxide, then the negative part of the reagent get attached to that unsaturated carbon atom which carries more number of hydrogen atom. So that rule is considered as a peroxide effect or anti-Markovnikov's rule. So here anti-Markovnikov's addition will take place and propene reacts with HBr in presence of peroxide. It gives you 1-bromopropene as a major product. Similarly, when propene reacts with excess of bromine in presence of higher temperature of about 800 Kelvin, it gives you 1-bromopropene as a major product. Similarly, when propene reacts with N-bromosuccinamide in presence of CCl4, it correspondingly gives 3-bromopropene as a major product. Propene reacts with HBr in presence of CCl4 gives symmetric addition, that is 2-bromopropane will be obtained as a major product. When propene reacts with HCl, it gives you 2-chloropropane, and propene reacts with bromine in presence of CCl4, it gives you 1,2-dibromopropane as a major product. So these are the various methods of preparation of alkyl halides. Similarly, various chemical properties are also observed by the chemical, they are alkyl halides. That alkyl halides, when reacts with sodium iodide in presence of acetone, it gives you corresponding alkyl iodide. So substitution of one halogen with the another halogen will take place, and hence that reaction is called as a halogen exchange method. When alkyl halide, when reacts with Gilman reagent, that is dialkyl copper lithium compound C2H5 twice CuLi, it gives you corresponding alkane as a major product. In that particular case, Core-Hauss synthesis will be observed. Similarly, when alkyl halide reacts with excess of ammonia under higher pressure, it gives you corresponding amine as a major product. When alkyl halide reacts with sodium salt of corresponding ethyne, which also gives you higher alkyne as a major product in step-by-step synthesis. Similarly, when alkyl halide undergo reduction in presence of LiLH4, it gives you corresponding alkene as a major product. When alkyl halide reacts with sodamide or NaNO2 in presence of DMF, that is dimethyl formamide, it gives you corresponding nitro compounds as a major product. Similarly, when alkyl halide reacts with sodium ethoxide, it gives you corresponding ether as a major product. So these are the various reaction gives you different functional group from your alkyl halide. When alkyl halide reacts with aqueous KOH or moist Ag2O, it gives you alcohol as a major product. Similarly, when alkyl halide reacts with KCN, it gives you corresponding cyanide, and when alkyl halide reacts with AgCN, it gives you corresponding isonitrile as a major product. When alkyl halide reacts with KNO2, it gives you corresponding nitroso derivative compound of the alkane, and alkyl halide reacts with AgNO2 to give nitroalkane as a major product. Similarly, when alkyl halide reacts with regular benzene in presence of AlCl3, it gives you Friedel-Crafts alkylated product, that is alkyl benzene. And alkyl halide, when reacts with RMgX, means Grignard reagent, it gives you higher alkane as a major product. Alkyl halide reacts with carboxylate anion to form corresponding ester as a major product. So these are the various chemical reactions of your alkyl halides. But in this particular case, for the nucleophilic substitution reaction, for SN1 reaction specifically, tertiary alkyl halides have higher rate than that of the secondary alkyl halides, which have higher alkyl rate than that of the primary alkyl halide. For SN2 mechanism, primary alkyl halides are more favorable than that of the secondary, which are more favorable than that of the tertiary alkyl halide. What is the reactivity order for the alkyl halide with respect to this particular different reagent? So it is depends upon the size of halogen atom. So alkyl iodide reacts faster than that of the alkyl bromide, which are reacts faster than that of the alkyl chloride, which are reacts faster than that of the alkyl fluoride. Similarly, when alkyl halides reacts with your active metals like sodium in presence of ether, it gives you corresponding higher alkane as a major product, and that reaction is called as a Woods reaction. Alkyl halides, when reacts with bromobenzene, it is in presence of sodium in presence of dry ether as a solvent, it gives you aryl benzene as a major product, or either alkyl benzene as a major product. But this reaction is called as a Woods-Fittig reaction. Remember that in both these reaction, active metal is a sodium, but in the first case alkane is obtained as a major product, whereas in the second case halogen derivatives or alkyl derivatives of your benzene are obtained. Similarly, when alkyl halide reacts with magnesium metal, it gives you Grignard reagent as a major product. When it reacts with alcoholic KOH, it undergo elimination reaction to form unsaturated product, that is alkene or alkyne. Similarly, when alkyl halide reacts with NaSH in alcoholic condition, it gives you corresponding alkene as a major product. When alkyl halide reacts with CH3SNA, that is a sodium salt of thio compounds, thiomethane, then that compound considered as a thioether will be obtained as a major product. So these are some various chemical reactions along with their reactivity order. Now, what are the physical properties of alkyl halides? So first physical property is a dipole moment. it wholly depends upon the electronegativity of the halogen atom, but due to bond dissociation, enthalpy of chlorine is higher than that of the fluorine. CH3Cl shows higher dipole moment than that of the CH3F, which shows higher dipole moment than that of the CH3Br, which shows higher dipole moment than that of the CH3I. Second physical property is bond enthalpy. So it depends upon electronegativity of halogen atom. So as the fluorine is most electronegative in case of halogen, CH3F shows higher bond enthalpy than that of the CH3Cl, which shows higher bond enthalpy than that of the CH3Br, which shows higher bond enthalpy than that of the CH3I. The boiling points of alkyl halides is wholly depends upon the size of halogen atom. So as we move from top to bottom in case of group 17, number of electrons increases and size of halogen also increases. So alkyl iodide shows higher boiling point than that of the alkyl bromide, which shows higher boiling point than that of the alkyl chloride, which shows higher boiling point than that of the alkyl fluoride. But in case of straight chain as well as the branched hydrocarbon or derivatives, primary alkyl halide shows higher boiling point than that of the secondary, which shows higher boiling point than that of the tertiary alkyl halide. Next property is the density. Density is directly proportional to mass, and hence as the halogen atom, size of halogen atom increases, mass of the halogen atom also increases. So N-propyl iodide shows higher boiling point than that of the N-propyl bromide, which shows higher boiling point than that of the N-propyl chloride. Mostly the last property is the solubility, and all these alkyl halides are slightly soluble in water as they are organic compounds, and hence they are directly soluble or readily soluble in organic solvent. One more important point is the trihaloalkane reactions. So reactions of trihaloalkanes consist of, first of all, haloform test, when corresponding methyl ketone reacts with chlorine in presence of NaOH, it gives you corresponding chloroform as a major product. When acetone reacts with CaOCl2, that is calcium oxychloride, that is also called as a bleaching powder, it gives you chloroform as a major product. When corresponding trichloroethanol is combined with NaOH in presence of sodium formate, it gives you again chloroform as a major product. When carbon tetrachloride reacts with Fe in presence of HCl as a solvent, it gives you corresponding chloroform as a major product. And when methane reacts with excess of chlorine in presence of radiant energy, it gives you chloroform as a major product. Similarly, when that chloroform further undergo oxidation in presence of sunlight, it gives you COCl2, that is a phosgene as a major product, which is a toxic in nature. When chloroform reacts with nitric acid, that is HNO3, it gives you corresponding chloropicrin as a major product, having molecular formula CCl3NO2, which is also called as a tear gas. Chloroform reacts with silver powder in presence of higher heat or strong heat, it gives you corresponding alkyne, that is ethine as a major product. Similarly, when chloroform reacts with phenol in presence of basic medium, it gives you corresponding salicylaldehyde as a major product, which is also known as a Riemann-Tiemann reaction. When chloroform reacts with methanamine, that is CH3NH2, it gives you corresponding isocyanide as a major product, which is distinguishing test for primary amine specifically. Now moving towards last part, that is nothing but your haloarenes. So generally in case of haloarenes, that is chlorobenzene undergo electrophilic substitution reaction in presence of concentrated HNO3 and concentrated H2SO4. It undergoes nitration reaction, and it gives you mixture of product, that is ortho as well as a para derivative, out of which para is obtained as a major product. When chlorobenzene undergo Friedel-Crafts alkylation in presence of methyl chloride and AlCl3, which is anhydrous in nature, it gives you 4-methyl chlorobenzene and 2-methyl chlorobenzene, out of which 4-methyl chlorobenzene is obtained as a major product. Similarly, chlorobenzene undergo electrophilic substitution reaction, that is in presence of acetyl chloride, it gives you again mixture of product, that is ortho and para derivative, out of which para is obtained as a major product. Similarly, when chlorobenzene undergo reaction with concentrated H2SO4 and CCl3CHO, it gives you important product, that is medicinally important DDT, which abbreviation for DDT is dichloro diphenyl trichloroethane. When chlorobenzene reacts with in nickel aluminium in presence of NaOH as a basic medium, it gives you benzene as a major product, hence it acts as a reducing agent. Chlorobenzene reacts with sulfonation in presence of concentrated H2SO4. It gives you ortho as well as a para derivative, out of which para product is obtained as a major. Chlorobenzene when reacts with chlorination in presence of FeCl3 followed by electrophilic substitution reaction, it gives you mixture of product that is ortho as well as a para dihalo derivative, out of which para product is obtained as a major product. When chlorobenzene reacts with bromobenzene, it gives you fatigue reaction and product obtained is a biphenyl. When chlorobenzene reacts with methyl bromide, it gives you Wood's fatigue reaction. It shows toluene as a major product, which is also called as a methyl benzene. When chlorobenzene reacts with sodamide in presence of liquid ammonia, it shows aromatic nucleophilic substitution reaction and it forms aniline as a major product. When chlorobenzene reacts with sodium hydroxide at higher temperature 623 Kelvin and 300 atmospheric pressure followed by hydrolysis gives you phenol, and that phenol reacts with generally most of the concentrated reagent, that is concentrated HNO3 as well as the concentrated H2SO4. It gives you picric acid, and that picric acid followed by hydrolysis again it undergo reaction with warm water, it form 2,4,6 trinitro chlorobenzene as a major product. Now, the reactivity towards different nucleophiles when substituted benzene derivatives, that is fluorine, chlorine, bromine and iodine, which are present as a substituent at a para position of nitrobenzene, then the reactivity order are as follows: ortho, meta as well as a para positions when occupied with the electron withdrawing group, then the reactivity order is as follows. Similarly, in case of boiling points, as the size of halogen atom increases, the boiling point is also increases. So that's why iodobenzene show higher boiling point than that of the bromobenzene, than that of the chlorobenzene, than that of the fluorobenzene. In case of dihalo compounds, when two substituents, similar substituent like two similar halogen atoms present at 1,2, 1,3 as well as 1,4 position of the benzene ring, then ortho compound shows higher boiling point than that of the para, which shows higher boiling point than that of the meta. And last point is the melting point of dihalo derivative. So para substituted compound is shows higher melting point than that of the meta, which shows higher melting point than that of the ortho compound due to symmetrical nature. Thank you.